In this lesson, we are going to be using the properties of logarithms, section 9.4. So first, let's take a look at the properties. The product property says that if we have the log base b of m times n, that is the same as saying log base b of m plus log base b of n. Okay? Quotient property says if we have log base b of m divided by n, that is the same thing as saying log base b of m minus the log base b of n. Now these should be very similar to you because it's just the opposite of when we had our b to the m plus n. Remember, we could break that down from the previous lessons. Okay, and last we have our power property, which says if we have log base b of u to the n, that is the same thing as saying, bring that n out front, n times the log base b of u. I'd like to quickly remind you that from the lesson before, we remember that the logarithm, log is not a factor, it is a function. So when we're saying log base b of u to the n, not times u to the n. So when we're taking these functions, we're actually taking log base b of m times n, not just m, right? So let's quickly go over some of these examples. This next problem here gives us two things. It tells us log base 9 of 5 is approximately 0.732 and log base 9 of 11 is approximately 1.091. So if I can fix this. First, we look at log base 9 of 5 over 11. Well, we just learned the quotient property, so this should be pretty simple. This is m over n, so we take m minus n, log base 9 of 5 minus log base 9 of 11. Plug these values in, so we get 0.732 minus 1.091, and we get approximately negative 0.359. Okay, so that is how we use our quotient property. This one says log base 9 of 55. How are we going to take our 5 and our 11 and get 55? Can we do that? Yes, we can. This 55 is the same thing as 11 times 5. So if we have 11 times 5, we know we're using the product property. So we have log base 9 of 11 plus log base 9 of 5. Plug those values in. You're going to get something around 1.823. And I hope it's okay that I didn't write those down. I hope you know that you can just plug those values right in. Oops, they're opposite. Okay, and last but not least, we have log base 9 of 25. How can we use one of these or both of these numbers to get 25? Well, we know that 5 squared is 25. So this tells me we should probably be using the power property, right? So if we have log base 9 of 5 squared, we know that we can just bring that power down. We have 2 times log base 9 of 5 now. So we get 2 times log base 9 of 5 is 0.732. Multiply that out. You get 1.4, 1.464. And that is the answer. So a couple examples. Make sure you write these down because we have a good example of all three properties: quotient, product, and power properties. Okay, our next slide is learning how to expand and condense our functions. So we want to look at the expressions log base 5 times 2x to the 6th. No. Log base 5 of 2x to the 6th. And what we want to do is figure out how we're going to use our properties to evaluate this or to expand it as far as we possibly can. So there's two things we can do. I see a product here, 2 times x to the 6th, and I also see an exponent. The only problem is this does not say 2x all to the 6th power. So we have to do the product first because that 6 is only in the x, right? So if we use the product property first, that will give us log base 5 of 2 plus log base 5 of x to the 6th. And now that the 6th power is around everything that it's being taken the power of, we can use that power property. So we get log base 5 of 2 plus, take it down to the front, 6 times log base 5 of x. Please make sure that you need to have the exponent around the entire thing. Otherwise, you have to use the product property first and then the power property. So this would be your final answer. We cannot expand this equation expression any further. So the next thing we want to do is condense the expression. So just like the last thing we did up here was the exponent, I like to get rid of these leading coefficients first when I'm condensing them. So if we do that, we get log base 3 of 7 squared minus log base 3 of x to the 5th. And we see a minus sign, so this must mean the quotient property. So if you remember in the quotient property, what's in front is also on top. So 7 squared, we get log base 3 of 49. And over, since we're using the quotient, now we are changing to division, x to the 5th. So we have log base 3 of 49 over x to the 5th power. And that is your answer. We cannot condense that any further. Last slide is taking a look at something we like to call the change of base formula. Now this is pretty cool because before we did not have a way to evaluate just any expression with log, but now we can. So if you have a u, b, and c that are all positive numbers with b and c both not equal to 1, then we can say log base c of u is equal to log base b of u divided by log base b of c. The cool part is if we can pick this b value, the base of the log, to be anything we want, and why wouldn't we pick 10 or e, right? Because those are something that we know that we can punch into our calculators. That's something we know that we can evaluate every single time. So if we take if we pick b to be 10, log base 10 of u over log base 10 of c, we know that we can plug that into our calculator. So also, if we took log base e, we know that that is the same thing as saying ln of u, right? So log base c of u is the same thing as saying log of u over log of c. And remember, this is base 10. And also ln of u over ln of c. The u stays on the top. The base goes on the bottom. You can remember that by knowing that the base is your foundation. The c, the base, is always going to be on the bottom when you change your base. So let's do a couple examples here. First, we're going to look at common logarithm. We want to evaluate this using the common log. So if we have log base 4 of 8 and we want to use the change of base, common log means we want to use log base 10. If you remember from your vocabulary loss lesson. So if we have log base 10 and our equation, our expression is log base 4 of 8, remember our base is the foundation, so we want that to go on the bottom, log base 10 of 4, and our u value goes on top, log of 8. So we get approximately 0.903 on the top and 0.602 on the bottom, and that will give us about 1.5. So remember, you want to take the common log, change the base to 10, and evaluate. Plug that into your calculator. Looks something like this. Okay? And natural log, the ln, or log base e. So if we take the ln of something, Same thing, we want to keep the 4, which is our base, on the bottom, ln of 4, and keep our u value on the top, ln of 8. So we're going to get approximately 2.08, and on the bottom 1.39, which is again going to give us 1.5. Pretty cool, because you can pick whichever base that you want, plug it into your calculator, and you're going to get the same value if you evaluate it correctly. So just remember that the base goes on the bottom when you're doing the change of base formula. And we'll just sum it all up really quick here. Product property. If you take the log base b of u times v quantity, you get log base b of u plus log base b of v. And quotient property, u divided by v, means minus. And power property, just bring that exponent right out front. If we are expanding and condensing logarithmic expressions, make sure that these have to have the same bases before you combine them. Otherwise, just remember your properties and move backwards. And lastly, the change of base formula. You can start out with a log base c of u and change that base to anything that you want. Just make sure that if you want to evaluate it, you either got to pick log base 10 or log base e, which is the same thing as the ln. And that will be the end of the lesson.